All right, hello and welcome to lesson number 3 of Finance and Recursion. Now, just before I start, I wanted to talk a little bit of housekeeping with you guys. So, hopefully you all got my Google Classroom notification. Yes, I've decided to cave to the pressure and use Google Classroom. In this day and age, we need a place online that we can meet up and discuss things and get resources and things like that. So I've decided to move on to there. What I'll do is I'll put a bit of an announcement and a link to every new video that I make, and you guys will just watch that. Now, the first part of all the videos is going to be a bit of housekeeping, just a bit of admin about what, when tests are, when SACs are, how I'm doing, if you care. And part 2 of the videos are going to be more about how you should set up your notes and what you need in your bound reference book. And the third part is just going to be the knowledge and skills that you need for each topic. So the third part of each video that I'm making is probably the one that you can most replace with a Drolo. So if you want to get a little bit ahead of on the knowledge and skills, please watch a Drolo. I would love if you guys did that and did a bit of, background research. I don't want to call it flipped learning because that's what you guys should be doing anyway. There's nothing flipped about it. Please do that first. And then look at my lesson, so that'd be great. Now, without further delay, let's just go into this lesson. All right, so we're looking at lesson 3, the rules for the nth term in a sequence, modeling linear growth and decay. So, keywords here, nth term, and we're looking at linear still. So, our 2 examples of linear are simple interest. So that's for linear growth. And then for linear decay, we had flat rate depreciation and also unit cost depreciation. And remember that you guys should have your notes all set out like this. This is the way I want you guys to set out your notes for this topic. It just makes so much sense. This topic has 5 distinct ways that you can use recursion and recurrence relations. So we should be setting up our notes like this. All right, let's get into it. So from last lesson, we need to be able to do a question like this. Now, I would ask you guys to pause and give it a go yourself. And now I'm going to give it a try. So a commercial oven has a purchase price of $38,000. We know that that's going to be our C0. Now C, I'm using C because the question asks for C. So C0 is, and I've drawn that so badly. Let me try again. C0 is 38,000. After 800 uses, the value of the oven was 16,000. That's called our scrap value. And we've got 800 uses here. Well, I'll show you guys how to use that in a second. Let Cn be the value of the oven n years after it was purchased. That's why we're using C rather than V. So assume that the value of the oven has been depreciated using the unit cost method of depreciation. All right, a recurrence relation, cool. We don't have D yet. So we don't have D, which is the difference that keeps happening every time period. In this case, we're using unit cost, so it's not even time period, it's every time you use it. To calculate D, you do 38,000 minus 16,000 minus the scrap value divided by the number of uses. In this case, it's 17.5. So the amount that it depreciates every time you use this oven is $17.50. Cool. Let's remind ourselves that it's D. All right, so a recurrence relation. We're going to be having C0 equals 38,000. Cn plus 1 equals Cn minus 17.5. Cool? Where the oven is depreciating in value by $17.50 every time you use it. All right, now let's look at today's stuff. The nth term. N can be any number. You might have 8, you might have 909. In this case, we've got an N of 50 years. So if you start with a principal of $500, so that's V0, and you get 10% simple interest rate per year, how much would we have after 50 years? N. Well, I hope you guys will appreciate that if you started with 500 and went up to 550, 600, and wrote out all of those until you got to 50, that would take you a decent amount of time, right? So we've got a faster way of doing it. And that is our equation for the nth term, which is this one here. And D is defined the same as it is before. So this is an equation that you guys should be writing in your notes right about now. So if you need to pause and write that in, go ahead and do that. And I want you guys to also write the heading, rule for the nth term. So rule for the nth term is to distinguish it from recurrence relation, because both of these things have Vn in them, but you shouldn't be confused and write down the rule for the nth term when it asks for recurrence relation and vice versa. You should write recurrence relation is these two things. Rule for the nth term is this thing. Now, why have I got this I equals VORN over 100? What's that? All right, glad you asked. So I equals VORN over 100 is the amount of interest that you earn. So you're going to start with a certain value, let's say it's 500 from the previous question, and you're going to earn interest on that value. So that might mean that you're earning $1,000 interest. So your I is going to be 1,000, and that's how much you've added on to your principal. Now, for you guys that aren't so confident transposing, and there's no shame in that, please write these formulas down. So if you're asked to find the principal, if you're given the interest, then write this formula. If you're asked to find the rate, then write this formula. If you're asked to find the period of a loan, then you do this formula. So it's easy as that. Write these three formulas down, if you need it, in your sheet of notes. Cool. So for flat rate depreciation, in comparison to simple interest, it's very similar to the simple interest formula for the nth term, except this time we've got a minus sign. So similar to the recurrence relation, where the only thing that was different was the minus sign, the only thing different here is the minus sign. So when you're doing depreciation, it's minus ND. So that's our rule for the nth term. All right, same thing for unit cost depreciation. It's actually the exact same. So these two slides are very similar. Let's look at an example. All right, the following recurrence relation can be used to model a simple interest investment. V0 is 3,000, Vn plus 1 equals Vn plus 260, where Vn is the value of the investment after n years. What is the principal of the investment? Well, that's pretty easy. V0 equals 3,000. That's the principal. And how much interest is added to the investment each year? Well, how much is it going up by? 260. So interest each year equals 260. All right, write down the rule for the value of the investment after n years. Well, we know it's simple interest. So Vn equals VO plus ND. That's the rule. We need to write down a specific rule though. This is our general formula. So we're going to write Vn equals, well, what was our starting value? 3,000 plus N times our D, our difference, how much it's changing by, 260. So that is the rule for the nth term after n years, so the value after n years. Now use this rule, use a rule, you're probably going to want to use this one to find the value of the investment after 15 years. Well, we want V15 equals 3,000 plus, well, n is 15, so we go 15 times 260. Which ends up equaling 6,900. So it's as easy as that. When you've got n equals 15, you're figuring out V15. which is 3,000 plus 15 times 260. All right. Use a rule to find when the value first exceeds 10,000. So let's write down our rule again for a refresher. This is 3,000 plus 260 times n, and I've written them in a different order because that's just the way I roll sometimes. So Vn, we're trying to figure out when this whole thing exceeds 10,000. So if we go 10,000 equals 3,000, the starting value, plus 260 times n, if we figure out what n is here, we're going to figure out how many times this has had interest added on so that it reaches 10,000. If we look back at our formulas, n is equal to our Vn minus V0 divided by our D. That was one of the formulas from a few slides ago. In this case, it's 10,000 minus 3,000 divided by 260, which is 26. Let me just go to a calculator to calculate that. I think I've forgotten. 26.9. So you think, oh, okay, the answer is 26.9. Wrong. You can't have 0.9 of a year. You only get interest at the end of the year. So this means that it only first exceeds this value of 10,000 at the 27th year. I want you guys to think about this. After 26 years, the value is going to be less than 10,000. It hasn't reached 10,000 yet. During that whole year, nothing gets added throughout the year. So it's still less than 10,000 that whole year. At the 27th year, finally you get a value that's over 10,000. So this 0.9, because it represents a fraction of the time period that we're talking about, and nothing actually happens in that time period, we have to round up to 27. So this is one of those examples where the question isn't going to tell you to round. You have to know that you have to round in this case. So think about that example because it is an important one. All right, next one. So the following recurrence relation can be used to model the flat rate of depreciation of a set of office furniture. Okay, V0 is 12,000, Vn plus 1 equals Vn plus 1,200, where Vn is the value of the furniture after n years. All right, what's the initial value? Well, V0 equals 12,000. That's our initial value. By how much does the furniture decrease in value each year? Well, I think I've seen a mistake here. This should be a minus. Apologies for that. I can't be bothered changing it. All right. So the amount that it decreases by, D, is equal to 1,200. Write down the rule for the value of the investment after n years. Okay. Our rule is Vn equals 12,000. That's our V0, minus n times 1,200. Okay, so it's decreasing by 1,200 each year. Use the rule to find the value after 6 years. V6 equals 12,000 minus 6 times 1,200, which ends up being 4,800. Oh, I hope I didn't get that wrong. If so, it's been immortalized in video for the rest of time. How long does it take for the furniture's value to decrease to 0? We want Vn equals 0. So 0 equals, what's our starting value? 12,000. 12,000 minus n times 1,200. Well, this one I think I can do in my head. You're going to shuffle things around to get n as the subject. N is equal to 12,000 minus 0 divided by 1,200, which is 10. Quick maths. All right. A photocopier in the office costs $6,000 when it's new. Its value depreciates at the flat rate of 17.5% of its new value each year. What is its value after 4 years? All right. So V0 is 6,000. R, little r, is 17.5%. So we need to figure out what D is. The way we figure that out is we go R over 100 times V0, which is, let's do this quickly, 17.5 divided by 100 times, and we'll put that in bracket, times V0, which is, what is it again? 6,000. 1,050. So our D is equal to 1,050. Now, after 4 years, we're going to have V4 is equal to V0 of 6,000 minus 4 times 1,050. Now, am I going to try to do this one in my head? Yeah, I will. That's 6,000 minus 4,200, which is 1,800. That one I'm a little bit more confident about. Okay. Well, today you're going to be doing 5C of Adrolo. I've been told to try and put an outro to my videos. I haven't figured one out yet, so maybe you'll see one at the end of me talking right now, but likely not because I'm a busy guy. All right, thanks guys.